All right, covalent bonding is different. Covalent bonding is when they share. And I'm not talking about metals share with each other. The metals and the nonmetals, they're opposites and they attract. The covalent bonding only happens between the nonmetals. So cover up all the metals on your periodic table. That's most of the periodic table. The covalent bonding, the sharing, the nonmetals only share with themselves. So covalent bonding occurs when atoms share electrons instead of giving and receiving. And they don't necessarily share equally. It's kind of like when you share with your older brother or sister, or maybe you're the older brother or sister and you share with your younger ones. It's not always an equal sharing, is it? Your mom says share, and it seems like I have an older sister. And when my mom said share, it was always my older sister got a little bit more than the equal 50-50. Yeah, I know how you older siblings are. Okay, so when we have a covalent bonding, the pair, and it could be one electron from somebody and they share with the other, but they're always shared in pairs here. So the pair is included in the outer shell. Remember, it's all about the outer shell, where the valence electrons. So the pair is included in the outer shell of both atoms. So it's kind of like the outer energy level or shell overlaps between the two. It's like you can think of it as holding hands or overlapping in that case. Covalent bonding occurs between nonmetals, only between nonmetals. Okay, so we look at the next piece down here. You guys should be following along on the picture here. What you have there is NH3, one N and 3 H's, and you have ammonia. So nitrogen has a space for 3 electrons. You see it there? You see the little red hydrogens on there? They've already kind of put it in there. Nitrogen has 5 valence electrons. 5 valence electrons. And so it needs 3 more. 3 more, and it's going to be stable here. So each hydrogen atom shares its 1 valence electron. So you have to have 3 hydrogen atoms because hydrogen only has 1 electron. I mean, that's total. That's all it's got. So we need 3 of the hydrogens to share with them. So in this case, we have 3 sets of shared electrons, and then we have one that's called a lone pair. So when you guys, we probably won't do anything with the lone pair of electrons in this class, but when you guys get into your chemistry class, that'll be important for figuring out, well, what shape does that molecule have? So we have a lone pair up top, and then all the other 3 are bonded pairs. They're sharing those electrons. Now notice that by sharing, nitrogen has 8 electrons. It's got the magic number, right? But if you look at hydrogen, hydrogen is so small it can't even hold 8 electrons. It's maxed out at 2. So it's one of the ones that are so tiny that the octet rule doesn't work for it. It's too small for that. We move on to the next one, and here's another substance that you know already, H2O. You probably knew the formula for water before you came into this classroom. So in this case, you see oxygen has a total of 6 electrons. That means it needs 2 more. It just needs 2 more electrons to be stable. And it's got a space for those 2. And the hydrogen that it's bonded with, each one has 1. So it needs 2 hydrogen atoms to give it those 2 extra electrons. So the oxygen has space for 2 electrons, and each hydrogen atom shares its 1 with it. Now again, the hydrogen is stable with 2 electrons. It doesn't follow our octet rule, but now if you count the number of valence electrons around the oxygen, there are 8. Oxygen is a clear gas at room temperature. Hydrogen is a clear gas at room temperature, and as much as you could kind of cool them down to way below 0 to get them to be a liquid, you wouldn't want to drink that at all. But when you bond them together, you get something that we flat out can't survive without. So we get something with totally new characteristics and properties. You have the lone pairs of the oxygen up top, where they're not bonded with anything, and then you have the shared or bonded pairs down below with the hydrogen. Okay. The next one here, covalent, the oxygen and oxygen bonded together here. Oxygen, we breathe in oxygen all the time. You are not breathing in individual atoms. You're actually breathing in oxygen molecules, and it's one oxygen atom bonded to another. You guys have probably seen oxygen when it's written. It says O2. That's an example. It's called a diatomic molecule. It's never alone. It's always bonded to itself. That's why we can have free, pure oxygen in the air, because it's bonded to another oxygen atom. If it weren't bonded, it would be totally unstable, and it wouldn't be in its pure form. So in this case, you see each oxygen atom has 6 valence electrons. But if they share 2 pairs with each other, then by sharing 2 pairs, they can each have 8. So this is called a double bond. Instead of a single bond where you share 1 pair of electrons, now you have a double bond where you share 2 pairs of electrons. So oxygen has 6 outer electrons. In O2, you can see it written there, each atom shares 2 electrons. So instead of sharing just 1 electron, it's going to share 2. So we have single bonds like in water, and then we have double bonds like in oxygen, and we can even have triple bonds, and that's as far as it goes. Like if nitrogen is bonded to nitrogen, it forms a triple bond. So we can have some really strong bonds between the atoms.